Welcome to March, the month when for many of us in the U.S., we get to experience the snowy cold of February begin to ebb and spring weather begin to make its entrance. In this episode, we'll explore the planets and let you know how to see them, as well as exploring a specific feature on the moon, a penumbral eclipse of the moon, and we'll also explore some of the best deep sky objects that are visible on March evenings in two lesser known but rich constellations. Just a reminder that we've posted part 1 of our eclipse special, which is all about the upcoming total solar eclipse that will cross the continental U.S. on a line from Texas to Maine on April 8th. The link to that episode is in the show notes. Part 2 of that special will be out soon, so if you subscribe to us on YouTube, you'll get notified as soon as it's released. So, needless to say, if you're watching on YouTube, please like and subscribe. And if you're listening on audio, please leave us a nice review on your podcast platform. We really do appreciate that. As always, we love getting your comments, questions, and suggestions. And you can always email us at astroguypodcast@gmail.com or leave us a voicemail at 973-404-0380. We have the Astro Guy podcast group on Facebook where we post a lot of information about astronomy and astronomers. It's a lot of fun. And we really want to have it become a fun forum for all our listeners and watchers of the show. The link to the Facebook group is in the show notes. If you'd like to help support the Astro Guy podcast and YouTube channel, you can buy us a cup of coffee. It's that simple. The money is used to maintain and update the equipment that we use to create and publish the show. We've left a link in the show notes. Thank you. Now, I hear some snow melting, so let's get to the March skies. Welcome to the Astro Guy podcast. I'm not an expert. I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem. Seize the night. Welcome to the Astro Guy podcast. I'm your host, Wayne Zool. As the saying goes, March often comes in like a lion and goes out like a lamb. Hopefully, that means the cold, snowy weather that February delivered, at least here in the Northeast, will over the month of March turn to warmer temperatures as spring arrives, soon to be followed by the greenery and all the beautiful colors that nature provides for us in the spring. It also means that for the U.S., other than in Indiana and parts of Arizona, we'll return to daylight savings time at 2 a.m. on March 10th, when we'll move our clocks 1 hour ahead. This, of course, means a later sunrise and sunset times, so keep that in mind, and don't forget to spring ahead. March 1st is also the start of meteorological spring. Astronomical spring, on the other hand, occurs on March 19th, when the sun crosses the celestial equator, moving into the northern celestial hemisphere, where it will remain until September. The event on March 19th is called the vernal equinox, and on this date, nearly every place on the planet will experience 12 hours of daylight followed by 12 hours of night. Of course, the daylight will continue to get longer until the summer solstice in June, when the sun will begin heading southward again in its annual path through the sky. In March, we see Mercury returning to the evening skies. The best date to spot elusive Mercury will be on the evening of the 24th, when at 7:30 p.m. daylight savings time, magnitude 0 Mercury will be almost 15 degrees above the western horizon in Pisces. Binoculars will help you to pick it out of the evening twilight glow. In a telescope, you'll see Mercury as a 43% illuminated crescent, spanning about 7.5 arcseconds in size. Keen observers should be able to spot it about a week before and a week after the 24th, but it will be lower on the horizon, making it more difficult to spot. On the morning of March 1st, you should be able to spot magnitude minus 3.9 Venus, shining in the morning twilight, about 5 degrees above the eastern horizon, about 20 minutes before sunrise. Even though Venus is very bright and shows a 91% illuminated disk that spans about 11 arcseconds in size, it will be low in the morning twilight glow. As the month goes on, Venus gets tougher to spot, and by about the third week of March, it becomes lost in the glare of the sun, where it will remain until it reappears in the evening skies later in the summer. On the morning of March 8th, if you have an excellent eastern horizon with the aid of binoculars, you might be able to spot the 5.5% illuminated crescent moon, just 5.5 degrees south-southwest of Venus. Spotting a crescent moon that small is a bit of a challenge, so you'll need an excellent horizon, and low-powered binoculars will really help. If you spot the moon with binoculars, see if you can see it with the naked eye, as it will be a rewarding sight. While you're at it, look for magnitude 1.27 Mars glowing faintly, just over 5 degrees west-northwest of the moon as well. This should be a gorgeous sight. Mars has reemerged in the morning skies, and it's low in the east in the morning twilight as March begins. On the 1st, use Venus as your starting point. Mars is about 3.5 degrees west-southwest of Venus, but it's much fainter at magnitude 1.27, making it more than 100 times fainter than Venus. On the 1st, Mars shows a disk a little less than 4.5 arcseconds in size. By the end of the month, Mars will rise at 5:28 a.m. and will have brightened slightly to magnitude 1.2, and its disk will have slightly grown to just under 5 arcseconds. Mars will continue to get better as it makes its way toward opposition in January of next year. Jupiter continues making its trek to the west towards the Sun. As darkness falls on the 1st, Jupiter is that bright yellow-orange star shining brightly in the southwestern sky. On the 1st, Jupiter is glowing at magnitude minus 2.17, and its ever-changing disk spans about 36 arcseconds in diameter. By the end of the month, Jupiter will have dimmed slightly to magnitude minus 2.06, and will appear to have shrunk to about 34 arcseconds. On the evening of March 13th, the 18% illuminated waxing crescent moon will appear a little less than 3 degrees north of Jupiter. This should be stunning to see. Later in April, Jupiter will be lost in the glow of the sun until it reemerges in the morning skies later in June, so get your Jupiter viewing in now before it's gone. Saturn is lost in the glow of the sun all month, and it will return to the morning skies in April. Magnitude 5.82 Uranus begins March about 8 degrees east of Jupiter on the 1st. The gap closes as the month goes on, with Uranus ending the month a little more than 3 degrees east of Jupiter. So Jupiter will be your aid in locating it, especially under light-polluted skies. Uranus can be easily spotted in binoculars, and its pale disk will span just under 4 arcseconds in a telescope. Neptune is in conjunction with the Sun on March 17th and will not be visible at all this month. The 8th planet in our solar system will return to the morning skies in April. The moon is pretty busy this month. On the evening of the 24th, going into the 25th, the moon will experience a deep penumbral eclipse. Unfortunately, the penumbra is the fainter part of the Earth's shadow, so while you might notice a very slight dimming of the moon, you won't experience the red to copper colors that are displayed during a total lunar eclipse. I've left a link in the show notes to a site where you can get timings for the eclipse from your location. In the early morning hours of March 3rd, most of the U.S. will experience a very close passage of the moon and the first magnitude star Antares in Scorpius. Folks in an area from Virginia to eastern Texas may actually get to see the star appear to graze the lunar surface, appearing to pop in and out as it moves behind mountains and craters. Those southeast of Florida and into South America will see the star completely disappear behind the moon. I've left a link where you can get timings for your location in the show notes. On March 14th, the 27% waxing crescent moon will appear 2.5 degrees west of the Pleiades. This should look very nice in binoculars. On March 3rd, the minor planet Juno will be at opposition, or opposite the sun in the sky, so it will rise when the sun sets and be visible all night. Juno is the third asteroid to have been discovered. It was found by German astronomer Karl Harding on September 1st, 1801. This rocky world spans just under 85 miles in diameter, and at its brightest can only be seen in binoculars or a telescope. On the 3rd, the asteroid is well placed in southern Leo and will be glowing at magnitude 8.7. A planetarium program like Stellarium will help you figure out exactly which quote-unquote star is Juno. This month, the lunar feature that we'll explore is the bright crater Tycho. Tycho is a famous crater on the moon's south side, named after Danish astronomer Tycho Brahe, whose observations of Mars helped Kepler determine that planets orbit the sun in ellipses, not circles. The crater itself is about 108 million years old. This has been confirmed based on samples that Apollo 17 brought back in 1972. Although not one of the largest, Tycho is one of the brightest lunar craters. It measures 85 kilometers, or 53 miles across, and plunges 4,700 meters, or nearly 3 miles deep into the lunar surface. Unlike older craters, Tycho's shape remains sharp and well-defined. When the sun shines directly overhead, its bright interior shines, surrounded by a unique ray system stretching for over 1,500 kilometers, or more than 900 miles. Even under Earthshine, you can see parts of these rays. Inside the crater, the walls are slanted and have terraces, leading you to a rough yet almost flat bottom with tiny hills and cracks from past volcanic activity. The central peak rises 1,600 meters high, nearly a mile high, with another peak nearby. The best days to see Tycho are when the moon is about 7 to 10 days old, but it can be seen well from first quarter to last quarter. The impact rays emanating from the crater can be observed with the naked eye. The crater can be spotted easily with binoculars, but a telescope will show it best. As always, we recommend that you use some type of lunar atlas to help you specifically find where these objects are on the moon. We've left a link in the show notes to a free program that you can download that has interactive lunar maps. Moving out of the solar system, we're going to explore some of the best objects to observe in two constellations that are well placed for observing on March evenings. But they're not as well known as some others, even though they're home to some beautiful and fun DSOs. Let's explore the constellations of Hydra and Monoceros. Hydra is a large constellation that spans more than 120 degrees across the sky, just south of the celestial equator. The brightest deep sky object in Hydra is the open cluster M48. This cluster shines at magnitude 5.8 and spans 28 arc minutes in size. It is comprised of about 80 stars and can be glimpsed with the naked eye from a dark sky site as a faint fuzzy patch about the size of the moon in the sky. In binoculars, the cluster will appear as a mottled patch, with several member stars being resolved. In a telescope, you can make out dozens of stars within the cluster. Locating M48 is relatively easy. Start at the magnitude 0.4 star Procyon in Canis Minor and sweep 11 degrees south and then sweep 8.5 degrees east and you'll spot M48. One of the most studied and photographed galaxies can be spotted pretty easily in Hydra. I'm referring to the barred spiral galaxy M83, which is often referred to as the Southern Pinwheel Galaxy. This galaxy is one of the closest barred spirals to us, lying at a distance of 14.7 million light-years. It spans 13 by 11.5 arc minutes in size and glows at magnitude 7.6, making it an easy target in binoculars. In 7 by 50 binoculars from a dark sky site, M83 appears as a small, slightly elongated glow that's brighter at the center. In my 70mm refractor, the core of the galaxy appears bright and the spiral arms are there, but they're not really defined. In a 6-inch or larger scope, the spiral arms become pretty well defined if your skies are good. This is one of the rare galaxies that you can crank the magnification a bit as well. Observing it with my 8-inch Dobsonian and an 11mm Nagler eyepiece, which yields a view of 90 power, the core and the spiral arms appear very well defined, and with prolonged careful observations, lots of details appear in the spiral arms. This looks amazing through larger instruments as well, but because it's pretty far south, it doesn't get very high in the sky. For those of us in most of the US, dark skies will definitely help you in trying to find this galaxy. To locate it, imagine a line from 3rd magnitude Gamma Hydrae to magnitude 3.3 Pi Hydrae. The galaxy is about 6 degrees south of the middle of that line. Our next object is a bright but small planetary nebula, NGC 3242, which is commonly known as the ghost of Jupiter. Visually, it does faintly resemble Jupiter's shape without the brightness or the Jovian features. In my 8-inch Dobsonian, you can see the nebula has a brighter inner core surrounded by a fainter outer halo. You can see it in binoculars, where it will appear as a faint, fuzzy star, but it will show best in a telescope. Using a nebula filter will help to bring out some of the details within the nebula. NGC 3242 was discovered by Sir William Herschel on February 7, 1785. The nebula glows at magnitude 8.6 and spans 25 arcseconds in size. It's located about 4,800 light-years away from us. To locate the ghost of Jupiter, start at magnitude 3.8 Mu Hydrae and sweep 1.8 degrees south, and you should spot the nebula. Our next three objects in Hydra are low on the southern horizon, so you want to make sure that you have a clear southern horizon to try to spot them. They are also located in the eastern part of Hydra, so in March, they won't be at their best until a couple of hours after midnight. That being said, I have observed all of these from here in New Jersey. Next on our list is the barred spiral galaxy, NGC 3621. In my 8-inch scope, this galaxy shows up as an almost rectangular glow, as the brightest parts of the galaxy appear almost as a rectangle in shape. Of course, long exposure images will show the true spiral nature of this galaxy. I've even been able to spot it with my 70mm refractor, but again, you'll need an excellent southern horizon and dark skies to pick it out with a smaller scope. The galaxy is listed at magnitude 9.6 and spans 9 by 4 arc minutes. It's located about 22 million light-years away from us. To locate NGC 3621, start at magnitude 3.5 X Hydrae and sweep 3 degrees west till you come to a magnitude 7.5 star. Then sweep 1 degree south and you'll spot the galaxy. A little higher and therefore a little easier to spot is our next object, the shell elliptical galaxy NGC 3923. It's called the shell galaxy because the stars appear to form in layers going outward from the core of the galaxy. The Hubble Space Telescope has been able to resolve more than 20 shells within this galaxy. Sadly, the shells are only seen in high-resolution, long-exposure images. In a 6-inch scope, this galaxy will look like an elongated glow, almost looking like an unresolved globular cluster. It will appear brighter at the center and fades away the further you look from the core of the galaxy. NGC 3923 is listed at magnitude 9.6 and spans 6 by 4 arc minutes in size and is located about 90 million light-years away from us. To locate NGC 3923, again start at magnitude 3.5 X Hydrae and sweep 4 degrees east and then 3 degrees north and you'll spot the galaxy. The last object in Hydra that we'll look at is brighter, and it's much easier to locate. Let's explore the globular cluster M68. This globular cluster contains more than 100,000 stars and glows at magnitude 7.9 while spanning 11 arc minutes in size. It is located 33,600 light-years from us, and it's approximately 106 light-years across. You can spot M68 in binoculars as a faint, unresolved glow, but in a 4-inch scope, you'll be able to resolve several of the cluster's stars. An 8-inch scope will reveal several dozen member stars in the cluster. This is a fun but often overlooked object because it's so far south. To locate M68, start at magnitude 2.65 Beta Corvi, known as CRAS, and sweep 3.5 degrees south and 1 degree east, and you'll see M68. Now let's explore some of the best deep sky objects in the constellation Monoceros, which is well placed on March evenings for observing. The brightest object we'll explore there is the open cluster NGC 2232. This cluster is listed at magnitude 3.9, and it contains about 30 stars and spans nearly half a degree and is located about 1,000 light-years away from us. In binoculars, you can begin to resolve the cluster, while in any scope you should be able to resolve most of the cluster's brighter member stars. To locate NGC 2232, Start with the 3 stars that make up Orion's belt. Follow that line in a southeasterly direction from Alnitak for 11 degrees, then sweep 5 degrees northeast, and you'll see the cluster centered on the 5th magnitude star, 10 Monoceros. Our next object is the famous Rosette Nebula, which is really 4 objects in one: the actual nebula and the open cluster NGC 2244, located within the center of the nebula. The Rosette, or Skull Nebula, actually has 3 different catalog numbers: NGCs 2237, 2238, and 2239. The nebula is listed at magnitude 9 and spans 60 by 80 arc minutes. The entire complex is located about 5,200 light years away from us. Even though it's listed at magnitude 9, it can be spotted pretty easily from dark skies with just binoculars. In a telescope, you can spot knots of bright and dark areas. There are several areas of dust and dark nebulae that stand out, including an area that is often referred to as the Parade of Animals, although those are some strange-looking animals. The cluster within the nebula, NGC 2244, is bright and easy to spot. There are several brighter stars making a rectangular shape at the heart of the cluster, including the magnitude 5.85 star 12 Monoceros. The cluster is sometimes called the HARP cluster, and it's listed at magnitude 4.8 and spans 24 arc minutes in size. It is thought to have formed from the gas and dust in the Rosette Nebula itself. Besides being beautiful to look at, the Rosette complex is easy to locate. Start at Betelgeuse in Orion and sweep 9 degrees east and then 2 degrees south, and you'll spot the Rosette. Located just 4 degrees north-northeast of the Rosette is our next object, NGC 2261, known as Hubble's Variable Nebula. This peculiar object is a reflection nebula that to me looks like a Halloween ghost, the sheet over the head kind of ghost. Because of the gas and dust around the star whose light the nebula is reflecting, it varies a bit in brightness, by up to 2 magnitudes over a period of just a couple of days. The star illuminating the nebula is R Monoceros. However, the star itself is not visible to us as it's blocked by dust. Because of the changes in brightness caused by R Monoceros, the nebula also appears to change shape slightly. An interesting note, NGC 2261 was the very first object ever imaged by the 200-inch telescope at Mount Palomar. That observation was done by Edwin Hubble. The nebula is listed at magnitude 9 and spans 2 by 1 arc minutes. It can be glimpsed through binoculars, but it is best seen through a telescope. Our last pair of objects in Monoceros is another 2-for-1, as it's a large, bright open cluster and a complex of emission and dark nebulae. The cluster and nebula are cataloged together as NGC 2264. The cluster is commonly known as the Christmas tree cluster, and it really does look a bit like a Christmas tree. The cluster is bright at magnitude 3.9, and it spans 20 arc minutes in size. The entire complex is located 2,350 light years away from us. Located at what would be the top of the Christmas tree is the brighter part of the nebula, known as the Cone Nebula. As in pictures, it appears to be a cone sitting at the top of the Christmas tree. The entire cluster is actually surrounded by emission nebula, but because of the dark nebula contained in the cone, it stands out. I've seen it many, many times in my 8-inch Dob, as well as other smaller telescopes. Locating this beautiful pair of objects is easy. From magnitude 1.9 Alhena, also known as Gamma Geminorum, sweep south for just over 6 degrees, and then sweep 1 degree east, and you'll spot the Christmas tree. I do hope that you'll go out and look at these objects, and that they become favorites of yours as well. Well, that's all for this month. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.